Hi everyone, today we are going to do ideal gas law stoichiometry. So a couple things we need to know is the 7 diatomic molecules. Okay, and that'll help us write balanced equations. And so there's really two kinds of problems here. Problems that are at STP, standard temperature and pressure, which let us use this conversion. 1 mole is equal to 22.4 liters. And so if it's at STP, all we have to do is use stoichiometry to get our answer. Okay, and so in this problem, it's asking how many liters of hydrogen will be produced from 16.7 grams of magnesium. So remember, stoichiometry, we take our starting amount and we're going to convert this to moles of magnesium by dividing by the molar mass. We get 0.69 grams of magnesium, but again, we're trying to get to hydrogen, so we're going to do a mole ratio conversion. Here, 1 mole of hydrogen is equal to 1 mole of magnesium, and again, that comes from the coefficients from my balanced chemical equation. So now I've got 0.69 grams of hydrogen, but again, 0.69 moles of hydrogen, but I don't want moles, I want liters. So for every 1 mole of gas at STP, and this only works at STP, it's 22.4 liters. And so if we multiply these numbers together, we get our final answer, about 15.4 liters. Okay. So again, at STP, you just have to use stoichiometry to solve this kind of problem. We first took our given information to convert it to moles. So that should be moles. Then we use the mole-to-mole ratio to try to get into our moles of gas. Once you get moles of gas, then you can multiply by 22.4 to get liters of gas. Okay, number 3 is going to be similar to that. So 2 and 3 are similar in that you just use stoichiometry because this is at STP. Number 4 is different, and that it's not at STP. So first thing we need is a balanced chemical equation. So it says how many liters of carbon dioxide gas will be produced. So I'm producing carbon dioxide gas, and I'm also making calcium oxide here. So calcium carbonate is decomposing, and I start with 75 grams of that. Okay, so we're trying to get liters of carbon dioxide gas. We start with this amount, and they also give us a couple other information. They give us the temperature and the pressure. So first, let's start by trying to get moles of gas. So for every 1 mole of calcium carbonate, about 100 grams. And again, this 100 comes from the periodic table. I just added the numbers up. .75 moles of calcium carbonate. But I want moles of gas, so I want moles of carbon dioxide. So I'm going to use the mole ratio to get moles of gas. And good. So we're going to first use stoichiometry to get moles of gas. And then the next step in this kind of problem is we want to use the ideal gas law, and we're trying to solve for volume here. So I'm going to plug in the numbers that I have. So pressure is 1 atmosphere. I don't know the volume. I just figured out how many moles of gas I have. So it's 0.75. R is always this number. And then the temperature, we can convert that to Kelvin, and that's 295 Kelvin. Yeah, I can solve for volume, and I get about 18 liters. Okay, so just to recap for this problem here, we are first using stoichiometry to get moles of gas That's what we got here. Once we get moles of gas, right, that's N, we plug it into our ideal gas law equation to solve for the unknown. Okay? Remember, anytime you use the ideal gas law equation, you want to convert to the correct units. So for number 5, for example, if they give you Celsius, you want to make that into Kelvin. If they give you millimeters of mercury, right, you want to convert that to atmospheres. So that's 1 atmosphere for every 760 millimeters of mercury. 0.987 atmospheres. And so number 5 is similar to number 4 in that we want to use stoichiometry first. And so we're going to use, it's asking how many milliliters, and we start with grams. So we're going to use stoichiometry. 1.5 grams of aluminum. For every 1 mole, there's 27 grams of aluminum. Moles of aluminum. But again, we're trying to convert to moles of gas. So here I want moles of H2 and this comes from the mole ratio, so I'm going to look at my coefficients here. So 3 moles of hydrogen for every 2 moles of aluminum. 0.0083. Okay, and that's moles of hydrogen gas. Now that I've got that, I can go ahead and plug in all of these numbers and solve for volume here. Okay, so I've got my pressure, I've got my temperature, I've got my moles, and I'm going to let you solve for volume here. Once you do get volume, it's going to be in liters, but this question's asking for milliliters, so make sure you multiply by 1,000 to get your final answer in milliliters. All right, on the back, let me help you by giving you some of these equations. So chlorine gas plus hydrogen gas, remember those diatomic molecules? That's the equation for number 6. For number 8, the equation looks like this. And then for number 9, the equation looks like this. Okay, we can assume they're all gases. All right, so follow my tips. Again, if it's at STP, just use stoichiometry. If it's not at STP, you need to use stoichiometry to get moles of gas, and then that'll allow you to use the ideal gas law, just like number 4 and 5 here, to plug in and solve for the unknown.